So with these, this is the most recent stuff. So the first part, the factoring, we won't use Desmos for, but then we're going to get into the graphing quadratics, and so we'll talk a lot about using Desmos for that. So if I am looking at our factoring, remember, first thing we always check for on factoring is greatest common factor. So let's look at number 3. What can I take out of both of these?
An A and B.
Yeah. So number-wise, the biggest option is 15, and we can also take out an A and a B to the second. Okay, when you factor it out, it's like dividing. So what's 75 divided by 15? I had 2 A's, I took out 1, so there is 1 left. I had 3 B's, I took out 2, so there is 1 left. I had a C, I did not take it out, so that stays. Minus 30 divided by 15 is 2. I took out the A, I took out the B squared, so that's gone. If you take out everything, what do we call it? Or what do you have left if you pull out everything? Like if I had taken out the 30AB squared, what would I put there? 1. So if you take out everything, make sure you put a 1 in its placeholder. If something can't be factored, what do we call it? Remember, there's a word, starts with a P prime. Something that cannot be factored is prime. Okay, greatest common factor is the first step. Then, if it had 2 terms, we look for difference of squares. So when I have 9k squared minus 1, what would that factor into? How do we do difference of squares? Remember, we do the square root. Square root of 9k squared is 3k. Square root of 1 is 1. One of these gets a plus. One of them gets a minus. How can you check yourself on factoring? Yeah. If you FOIL everything out, it should give you the original. All right. Trinomials. Let's look at problem 7. So on these, I'm looking for numbers that multiply to my constant and add to the middle. So I need 2 things that multiply to a positive 30 and add to a negative 13. What would that be?
No, negative 10.
Negative 10, negative 3. So we write P minus 10, P minus 3. And if we had a trinomial where the first coefficient was not 1, so like problem number 11, what would I have to do there? Slip and slide. So remember, we start out multiplying our 12 down. So now I need 2 things that multiply to a negative 24 and add to a positive 5. So that would be what? Positive. Those don't add to 5 though. So 12 and 2 multiplies to 24, but it doesn't add to 5. What else could I do? Yep. Positive 8, negative 3. And then what do we do to each of these? That's only if we're solving. Here we're just factoring. So we divide by 12. 8 over 12 reduces to 2 over 3. So remember the 3 slides in front, so it's 3c plus 2. 3 over 12 reduces to 1 over 4, so the 4 slides in front, so 4c minus 1. So we don't have to set these equal to 0 because all we are doing is factoring, not solving an equation here. Are those okay? All right. So let's do a few that have multiple steps. If I look at problem 13, always check for greatest common factor first. So nobody should be on their Chromebook right now. We're factoring, we're on paper. Remember, you get credit for all of these that you write down. What would I have to do first? Take out 12. So that leaves me with x squared minus 12 divided by 12 is 1. But x squared and 1, those are still perfect squares. So that can factor with a difference of squares. So the square root of x squared is just x. We get a plus and a minus, and the square root of 1 is 1. If I look at 15, is there a greatest common factor we can take out? No, nothing goes into both. Okay, are they both perfect squares? No. So if I can't do anything, what do we write? Prime. 21. What can you take out of all those? 3. So if I take out the 3, h squared minus 6 divided by 3 would be a 2h plus 3 divided by 3 is 1. Well, that can factor further. Come in. What two numbers multiply to 1 and add to negative 2? So it would be h minus 1, h minus 1, negative 1 times negative 1 is 1, negative 1 plus negative 1 is negative 2. All right, are we doing okay with those? Okay. Let's talk about the quadratics. So our standard form is the ax squared plus bx plus c. Our vertex is a times x minus h squared plus k. We can see it written either way. The axis of symmetry, if it's the first way, we always found it by doing x equals opposite of b over 2a. And the second way, we thought about transformations. On the EOC, what other resource can you use to help you? Does No, go ahead. What did you say? The table?
That's like we don't never mind. Like, don't we have that paper too? Does it have that equation?
Yeah. So our paper has on our formula sheet. It has the vertex form. Yeah, it has both of these. It doesn't label which is which, but it does not give you the equation for finding the vertex. So the opposite of b over 2a is not on here, but the equations themselves are. All right, so look at 25. If I ask you to do the table of values, we always went to the middle of this table and we put in the vertex. So we had to find the vertex. Now when we were doing it in class, I made you do the formula to work it out, but we know we have Desmos. So why don't you guys plug this into Desmos for me? So we can use Desmos for the vertex and for those zeros. So those are at 2 and 4. You can write them as ordered pairs or list them. The y-intercept, where we hit the y-axis, we could also look on Desmos. I'm going to have to move that, but my y-axis, my point is at 8. Or 0, 8, if I ask for an ordered pair. So, graphing these quadratics, use Desmos. If you need a table, use your graphing calculator to get the table. Is that okay? All right, let's talk about transformations a little bit. We've struggled with these a little more. So I want to talk about using our resources. If I asked you, given this equation, describe the parent function from the equation y equals x squared. So if I really want a visual for my transformation, let's say I couldn't remember exactly what this did, we could graph them. I'm going to go ahead and graph the original y equals x squared first. So that's what a parabola should look like. Ours was negative 2 times x minus 4 squared. So what's the difference? It flipped over the x-axis. It moved to the right 4, so it went right 4, that's what the minus 4 did. It flipped, that's what the negative did. Can you guys tell what the 2 did? Yeah, it made it thinner because it was a vertical stretch. So if I'm describing those transformations, it flipped or reflected over the x-axis. It went right 4. And it was a vertical stretch because it got skinned. That's what the 2 did. Okay, so if I go to 35, this time they're telling me the transformation and I have to write the equation. If it reflects, what causes something to flip or reflect? Okay. If it goes 7 to the left, so kind of model it off this, we have an x, we're going to have a square. If I move it to the left, what would I have to do? And up 1 would be plus 1. If you want to check yourself, what would you do with that? Put it into Desmos and make sure. If your equation made it move to the right, then you could fix it at that point. So use Desmos to double check yourself there. Is that okay? All right. Last thing we did on here was solving equations. So the solutions are the points where it hits the x-axis. Remember, there's a lot of different things I could ask. I could ask you to find the roots or the zeros or the x-intercepts. They all mean the same thing. So if we want to solve one of these, so like problem 47, we always first got it equal to 0. This is what we were doing on our last test. So we have 4x squared minus 10x equals 0. Those outlets don't work. You'll have to go over behind Jaden. That one works. How could we factor this? What could we take out? A 2 and x. So 4 divided by 2 is 2. We had x squared, we took 1 out, so there's an x. Minus 5, or 10 divided by 2 is 5. We took out that x. And once we have it factored, what did we do? Divide. We get 0. And 5 over 2. If you are trying to check yourself on this, the best option is to graph it once it's equal to 0. So not the original, that's not going to work, but if I graph the 4x squared minus 10x, then I can look. Here's where I hit 0. So that's at 0. And 2.5. Is 2.5 the same as 5 over 2? 5 divided by 2 is 2.5. So it gave us the decimal form, but they are equivalent. So if you're wanting to check, use Desmos, you're looking for the x-intercepts, where it hits the x-axis. All right, last problem of the day. Want to go to problem? These are kind of out of order because I cut and pasted some things. But problem 50. The dimensions of a rectangle can be represented by the expressions x plus 7 and x minus 3. If the area is 75, find the value of x. How do we get area of a rectangle? Length times width. So my area we said was 75. The length is x plus 7. The width is x minus 3. All right. So we can work all this out. If we want to be able to use Desmos, what would I have to do at least? What did we do on the last one? We had to make it equal 0 first. What would happen? Let's see. If we just subtract over that 75. Let's see if it'll graph it for us. So we have x plus 7 times x minus 3 minus 75. Okay, if I zoom out a little bit, it gives me a graph. What points am I looking for? Yeah, where it hits the x-axis. So my answers are 8 and negative 12. Okay, so I just used Desmos to solve that. The only key is it has to be equal to 0 before you put it into Desmos. So x is 8 and negative 12. Now, if you're talking about a rectangle, can we have a negative side? No, if I put in negative 12 plus 7, that's negative, so that's not going to work. So, in the context of this problem, because x is the length of a side, it would have to be the positive 8. All right. Any questions for me? So we have a quiz tomorrow, much like the last one. I'll do some problems when we first come in as a refresher, and then we'll take that quiz. So your problems for tonight, I want you to do 2, 4, 8, 10, 14, 18, 19, 26, 28, 30, 32, 34, 36, 38, and the very last question, 52.